Today we discuss about human eye and colorful world. Okay, how the competitive questions they are asking on the topic of human eye and colorful world. In the topic of human eye, first main important number of questions they are asking is about the parts of the eye here. Okay. Now, when see the structure of the eye, main important one we are having is at first we are having a lens. So, which is our eye lens is a convex lens, that is which forms a converging images which are real and inverted images, that is the first important main part we have eye lens. And after that we are having to holding that eye lens, we are having two clips are adjusted here like this, two clips we have. These two clips we call that as ciliary muscles, those are called as ciliary muscles. Now, these ciliary muscles actually what they do is, here these ciliary muscles are keeping that eye lens tight, and not only that they are adjusting the radius of curvature of this eye lens here. Okay. Now, before that we are having the ciliary muscles, we are having one important like window part we call, that is called as iris, that is this is called as iris, I-R-I-S. Okay. Another important part that is of iris, that is iris actually it allows the amount of intensity of light, which is entering into the eye lens here. It try to adjust the amount of the light rays which are coming inside here. Now, the path or the passage where the light rays are entering inside, that part we call that as pupil, that is. Next part important one is pupil. And before this pupil we are having a protecting layer we have, of which we call that as cornea, that is. This is called as cornea. Now, whatever the light rays which are entering onto the eye lens here through the passage pupil here, after refraction is over, the light rays are going to meet at a point, that point only we call that as image formation here. For our eye lens, the image is formed on the part called retina, that is called as retina. So, retina is acting like a screen for our eye lens here. Here we will have the retina here. On the back side of the eye lens, we have this retina is present, retina. Okay. And here of course, we are having that optical nerves are starting here like this. This is the part of our eye lens, that is. Main important one is the eye lens, the ciliary muscles, iris, pupil, cornea and retina here. Okay. Now, most of the cases the questions coming on these parts of the human eye is mainly about their functions they are asking. How each part is important to see any of the different objects which are present around us. That is what important in case of this eye lens. So, before seeing that what are the important main functions here, some numerical values we have to remember, that is of when you are seeing any of the object which is very much closer to you, then the minimum distance to be maintained to see that object very clearly, that only we call that as least distance of clear vision, that is, or least distance of distinct vision, that is least distance of clear vision, that is, or distinct vision, that is least distance of clear vision. That L value actually it is equal to 25 centimeters, that is. So, what do you mean by this 25 centimeters means, when you are keeping the object at 25 centimeters, so that we can see the complete size of the object very clearly without any problem here, without getting the straining the eyes here, we can see that object very clearly, that is. Okay. That distance only we call that as least distance of clear vision. So, if they want to ask an MCQ on this one, they will ask like this, what is the value of least distance of clear vision for average person? So, most of the cases the distance it is of 25 centimeters, that is that average value. But when come to the case of infants like small children, if you are taking, for them it is ranging in between here actually from 10 centimeters to 15 centimeters also possible, that is. Okay. So, for the case of adults at an average that is about 25 centimeters, whereas in case of infants if you are taking small children, that is around 10 to 15 centimeters we have. But when come to the case of this aged people, if you take, whenever if age is growing here increasing, gradually this least distance of clear vision also gradually increases, that is. So, which means that it is around, depending on the person here, for an average we are having, it is about around 1 meter also possible sometimes. Okay, it is in ranging between 70 centimeters to 1 meter also possible, that is. So, like this, most of the cases for an average person, the least distance of clear vision without getting straining the eyes, if you want to see the object very clearly, the minimum distance to be maintained is 25 centimeters, that is. Okay. And another important one we have to see is about the distance between the eye lens to our retina, because our eye lens, which is a convex lens, and retina is nothing but acting like a screen here. It is called the diameter of the eyeball, or the image distance in terms of our physical terms if you see. Okay, that is called as image distance. So, image distance actually here it is always fixed, and we are having a length of about 2.5 centimeters, that is, which means from the eye lens to the retina the distance is about 2.5 centimeters, that is. So, that is the image distance, or you can also call that as the diameter of the eyeball. Actually, this also average value, for person to person it may change here. Okay. So, at an average we are having 2.5 centimeters, that is the average minimum distance we are maintaining from eye lens to the retina here. So, most of the cases the questions on this one is, actually this retina distance is always fixed, we cannot change this retina distance. Actually, when forming the formation of image, if you are using the lens formula there, 1 by f is equal to 1 by v minus 1 by u. As we are seeing different objects around us, the distance to them is not same. Every time the distance is changing here. We can see the near distant objects, or you can see the far distant objects here. So, that is why here continuously this object distance is changing here. U is changing continuously, but whereas in case of this image distance will never change. So, U always change depending on the distance of the object, okay, for near distance and for far distance. So, continuously there may be a change of object distance is possible, but here as we seen that from the lens to the retina, which is our diameter is fixed here, which is 2.5 centimeters, which is nothing but our image distance. Image distance never change, that image distance V value always it is of 2.5 centimeters only fixed there. Okay. So, that is why here as 1 by f is equal to 1 by v minus 1 by u, in that formula as u is changing and here as v is not changing here, which is always fixed. That is why here we have to adjust the focal length of the eye lens to see the object clearly, which means that after refraction the light rays has to converge exactly onto the retina here. So, that is why here we have to change this focal length. Then here only our ciliary muscles are working here. When you are seeing the far distant objects or the near distant objects, this depending on the distance placed that object is. Now, here what happens there is the focal length of the eye lens is continuously changing here, depending on the object and object distance, that is. And this work is done by our ciliary muscles, that is. This is what done by ciliary muscles. The main important theme of this ciliary muscles is depending on the object distance, it is adjusting the eye lens here, the focal length of the eye lens here. Means as it is changing the focal length of eye lens means it is changing the radius of the curvature. So, when there is a change in the radius of curvature causes changes in the focal length, so that we can see different objects very clearly, even though the distance from one object to the another object is different here. Okay. That work is done by ciliary muscles here, and we already know that our eye lens, which is a convex lens, our convex lens at the middle we are having more bulging part, we have more thickness is present, whereas when come to the case of edges, gradually the thickness is decreasing and it is very sensitive, that is, so that easily it is flexible to move upward and downward. Whenever if the object is seeing the far distant objects, these ciliary muscles actually when you are seeing the far distant objects, they are relaxing backside. So, that what happens there is an increase in the radius of the curvature here. So, that is why the questions coming on the case of this eye lens is they can ask like this. When you are taking the case of eye lens, is that eye lens is forming a real image or not? Yes, it forms a real image. And not only that, they may ask which nature of the image is formed by our eye lens. Eye lens actually, as I said, it is like a convex lens. As it is a convex lens, it forms most of the cases a real and inverted images are forming. So, which means that the image which is forming on the retina, which is on the screen, that is an inverted image it is forming here. Okay. Now, from this eye lens, these type of questions they will ask, which type of image is formed on the retina, and is that a real or is that a virtual, like these questions they will ask. Okay. And when come to the case of ciliary muscles, as I said, they will ask about the important part, what this ciliary muscle is doing there. Ciliary muscles, actually what it is doing is, as I said, it is adjusting the focal length of the eye lens here. The main important thing on this adjusting the ciliary muscles is, whenever if you are seeing the far distant object, the maximum focal length has to be available for this eye lens here. We have to adjust the eye lens to its maximum part here. So, maximum part we have to use, that means the maximum focal length for our eye lens that ciliary muscle can manage is, it is equal to our diameter of the eye lens, that is, which is nothing but the image distance, that is. Okay. So, the maximum focal length that our ciliary muscles can adjust the eye lens to see the far distant objects is equal to nothing but 2.5 centimeters, that is. Okay. And at the same time, whenever if you want to see the near distant objects, minimum focal length is to be adjusted for our eye lens here for the focal length there. So, that minimum focal length it is around 2.27 centimeters, that is. Okay. The maximum focal length, if you want to see the objects very far distance, the eye lens has to, that ciliary muscles have to adjust the eye lens by 2.5 centimeters focal length, whereas if you are taking any of the near distant objects, the focal length to be maintained is 2.27 centimeters, that is. So, which means that whenever if you are taking these far distant objects here, which are of very long distance if you are taking, then the ciliary muscles are moving backside, which are going to the relaxed position there. So, that what happens there is that the diameter of the eye lens is gradually increases. So, the radius of the curvature for the eye lens is increasing here. So, that the maximum eye length that can increase, the focal length it is of equal to our diameter of the eye lens, which is 2.5 centimeters. Now, the question coming on that will be like this. If you want to see a far distant objects, then the radius of the curvature of the eye lens, which is, we can take the options like this. It may be less, it may be more, it remains constant, and we cannot see. Actually, here in this case, as you are seeing the far distant objects, the radius of the curvature we have to increase that, because as we are seeing the far distant objects, the u value has to be more here. That is why here, as it is not possible to change the v value, obviously that f we are changing that. That done, what work done? That work is done by our ciliary muscle here. That work is done by our ciliary muscles. But whenever if you are seeing the very near distant objects here, those near distant objects we can see very clearly here by using the ciliary muscles, so that it can adjust the focal length to its minimum value, where that minimum value it is around 2.27 centimeters, that is. Okay. Now, the question on this also again they will ask like this. Whenever if you are seeing a very near distant object closer to your eye, then what about the focal length of the eye lens to be maintained? That length to be maintained is nothing but 2.27 centimeters. Okay. So, which means that the range where this ciliary muscles can adjust the focal length of the eye lens is, it is in between 2.5 to 2.27 centimeters, which means our eye lens is flexible around 0.23, that is. So, means we can adjust our eye lens here, which can be stretchable or which can be flexible up to 0.23 centimeters. This work done by our ciliary muscles. Okay. Now, when come to the next case, which is the importance of iris, if you see. Now, the questions based on that iris is, actually iris is doing the work whenever if you are seeing a high intensity light or a low intensity of light here, then what happens there is, when you are seeing a high intensity light, as our eye lens is a very sensitive one, when you are exposed to high intensity of light, then it may be possible, it may be possible, there is a possibility of having that high energetic beam light rays directly if they enter onto your eye lens, they may destroy our eye lens here. So, that here what happens there is, whenever if this iris if you are taking, when you are exposed to the high intensity of light, then what this iris do is, it is adjusting the size of the pupil here, it is adjusting the path which is coming inside those light rays. If you are exposed to high intensity of light, it is making the light rays to come through a small narrow space, that is, which means it is decreasing the width of the passage where the light rays are entering by moving forward and backward here. like this. It comes closer when you are exposed to high intensity of light, and if you are in a dim light there which is of low intensity of light is present, they are expanding backwards. So that what happens there is more amount of light can enter inside that. So that is the work done by our iris here. Okay. So here what is this question? The questions coming on this iris part is, they may ask like this: the passage of the path, the light rays which are incoming is controlled by, actually the path, the passage there, okay, which is the width where the light rays are coming inside, that is controlled by our iris here. And not only that, they can ask the question like this also: when you are exposed to a high intensity beam of light there, so that what about the iris? Iris actually it contracts so that it allows the number of light rays very less inside that eye lens, because those high energy intensity lights, they may burst our eye lens here. That is the problem. Okay. And in the same way, like these general cases, they will ask, if you are standing outside in a sun daylight, that is, then what about the position of the eye rays? Now, when you are exposed to the sun beam there, sun light rays there, then what happens there is, as you are outside during hot summer days there, so that what happens there is, whenever the sun light rays are directly coming onto your eye lens, then as they are coming directly onto your eye lens, they may damage our eye lens here. So that is why iris adjust the passage of the light rays to come inside, so that we narrow space, that is, so that it is decreasing the width of the passage there, so that it can come very easily, that is the light rays, and it is not damaging our eye lens. And in the same way, if you are inside a dark room where we are having a small amount of light, less intensity of light is present, in those cases what happens there is, here the iris extend backside, so that we can see very clearly the objects around us, so that more amount of light is entering onto that. So means the amount of light which is coming inside, that is managed by which part of the given parts eye lens, ciliary muscles, iris, pupil and cornea is iris. Okay. Iris is doing that work. Then what is this pupil is? Pupil actually it is a passage here. Okay. Pupil is nothing but a small hole of which where the light rays are coming inside. So whatever the passage it is following, the light path followed here, the path where the light is coming inside, that width or the passage we call that as pupil. This pupil actually it is adjusted by our iris. Whenever if the iris, if it is exposed to the high intensity lights, as I said, they are contracting here, which means that the passage width is decreasing. So which means pupil size is decreasing, that is. Whereas if you are exposed to the low intensity of light, which is a dim light if you are seeing, then the iris is expanding backside, so that the width of the window or the width of the passage here increases. So that what happens there is, the size of the pupil is increasing here. So which means they can ask the question like this: whenever if iris is extending backwards, what about the size of the pupil? Whenever the iris is extending backwards, the size of the pupil actually gradually increases, that is. And they can ask like this also: if you are in a very high intensity, if you are exposed to high intensity beam, what about the size of the pupil? The size of the pupil when you are exposed to high intensity of light is, as it is of high intensity of light, the light rays which are coming inside has to be less. So that is why here in this case the pupil size should be less when compared to the previous case. Okay. So like this, depending on the intensity of light or amount of light which is coming onto the eye lens, this ciliary muscles is adjusting the focal length. At the same time here the iris is adjusting the passage of the light rays to come inside. Whenever it is adjusting the passage more, then more number of light rays may enter. Whenever if the passage width is less, so that we are having less number of light rays may enter into side. Okay. So that is the work done by the iris, which is adjusting the size of the pupil, which is having more in size of the pupil, means more number of light rays are coming. Whenever if you are having small size of the pupil, then what happens there is less number of light rays may enter here. Now when come to the case of cornea, cornea is like a shutter here, which means that is acting like a protecting layer for the eye lens whenever the light rays are coming from outside here. Okay. So that cornea is acting like a protecting layer which is placed before this iris we have. Okay. Whenever the high intensity beam of light rays are coming here, that cornea tries to stop those light rays here, so that it allows a few number of light rays only to come inside, that is. So that cornea is acting like a protecting layer. In between this cornea and the iris, here only we are having a liquid surface, we call that as aqueous solutions we have. Okay. Now, after that we are having retina is there, another important one, where our retina is nothing but acting like the screen. This is nothing but our screen, that is. Okay. So, which means here the retina is acting like a screen, means whatever the light rays which are incoming here, where they pass through this pupil here, which is adjusted by the iris, when passes through our eyelids here, which is adjusted by our ciliary muscles, all the light rays are going to converge at a point. That point where if it is the retina, then what happens there is we can see a very clear image. So, means whatever the light rays which are coming inside, all that is collected on the retina, of which we call that as image, that is. But remember, on the retina here, as the convex lens forms a real image, the image formed by that is an inverted image on the retina, and it is taking up by using the optical nerves, it is sending the message to the brain. That is the work done by our retina here. So, retina is nothing but acting like a screen in case of our eyelids. So, these are the importance of each one in case of our eyelids, like the ciliary muscles you take, iris you can take, pupil you can take, cornea you can take, and retina, that is. Now, we will see the questions coming on defects of eye. Now, the next one is about defects of eye here. Now, as we seen the importance of each part there, about our eyelids here, which is about our human eye here. Now, we are seeing the importance, the defects which is caused due to this eye defect, that is. Okay, the defects of eye. Now, most of the cases our defects of eye, we are having mainly three are there, okay, which is about the short sight, which is also called myopia, and another one, second one, we call that as long sight, which is called hypermetropia, that is, and next one we call that as presbyopia. Okay. So, these are the three defects we are having: myopia, hypermetropia, and presbyopia, that is. Okay. Then, when come to the case of myopia, hypermetropia, or presbyopia, all these three cases the defect of eye is causing because of due to the failure of ciliary muscles here. As earlier we discussed about the importance of how these ciliary muscles are working. These ciliary muscles actually they are giving they are adjusting the focal length of eye lens to a maximum of 2.5 I said to a minimum of 2.27 here. Okay. Now, when come to the case of myopia, the short sightedness coming is due to because whenever the eye lens is adjusting, our ciliary muscles is adjusting the focal length of eye lens, sometimes it cannot adjust the eye lens to a maximum or it cannot adjust the eye lens to a minimum case here. So, because of due to that only we are getting these three types of defects, which is of myopia, hypermetropia, and this presbyopia, that is. Okay. Now, the first one if you are seeing about myopia, if you see, which is we also call that as short sightedness. Okay. Myopia, it is also called short sightedness, short sight. Now, short means which is of a near distance, that is. Sight means we can see very clearly, that is. Okay. Sight means vision, that is. Okay. So, which means that we are having a near distant objects which we can see very clearly, that is the meaning of short sight, that is. Now, here as we can see the near distant objects very clearly, so means our eye lens, that ciliary muscles, we do not have any problem to see the near distant objects, which means it can manage the minimum focal length. So, means that minimum focal length which is of 2.27 centimeters is managed. There is no problem to 2.27 centimeters adjusting the focal length here. Now, this myopia problem is we cannot see the far distant objects clearly, but we can see the short distant objects very clearly, that is. We can see very nearly the we can see very clearly that near distant one, but problem is with the far distance one, that is. As you cannot see the far distant one means which is nothing but the F maximum, that is of 2.5 centimeters is not adjusting here. This is the problem in myopia, and the number of questions are also asking about this only. Due to the case, whenever if you are having, if any person is affected with a having a defect of myopia there, then what about the focal length of the eye lens adjusting here? Okay. So, the focal length adjusting here is 2.27 centimeters, we do not have any problem. Whereas, in case of if you are adjusting the maximum focal length here, which is of 2.5 centimeters, it cannot manage up to 2.5 centimeters, it is relaxing just before that only. So, that what happens there is, when it is forming the image on the retina here by this light rays, then what happens there is, as the focal length is less, then what happens there is, the light rays are forming the image before the retina only. That is the problem. Because if you are having the maximum focal length of 2.25 and 2.5 centimeters, that is, so that they are forming the image exactly on the retina. But here the focal length is short by 2.5 centimeters, actually it is less than that 2.5 centimeters we have. So that what happens there is, the image is formed is also before the retina only. So means whenever the light rays which are passing through the retina here, as they are converging before the retina, when these light rays strikes the retina, they are going like a diverging beam. So that is why here what happens there is a blur image is formed instead of forming a correct image, that is. So based on this myopia, mainly they are asking which type of the defect we are having with myopia. The defect we are having with myopia is, that is of short sight, that is, which means we can see the near distant object clearly, but not the far distance. And the next question they are asking about, what is the reason for this myopia? That question actually here, as I said, what is the reason for that is, when you are taking these ciliary muscles adjusting the focal length, as it can see very clearly the near distant objects, which means that the minimum focal length is arranged. But whereas when you are seeing the far distant objects, it cannot manage up to 2.5 centimeters here. Now the answer it is going to be, as it is not adjusting the focal length to maximum of 2.5 centimeters here, that it cannot apply it cannot see the far distant objects clearly. That is the defect of myopia, that is. Okay. And the next question they will ask, it is about how much distance we can see that myopia defected eye can see very clearly the object. That point only we call that as far point, that is. We call that as far point. Far point is nothing but the maximum distance that myopia defected eye can see clearly the objects, can see clearly the object. See, as I said, myopia is nothing but short sight, we can see near distant objects clearly. So, but as I said, as we can see the near distant objects clearly, means we should have a particular range for that or not. So, here that far point distance is nothing but, the maximum distance, the point where we are having that maximum distance, so that the myopia defected eye can see the object very clearly. That point only we call that as far point, that is. Okay. So, up to that far point we do not have any problem. So, once if you are taking the object above that far point only, we are getting the problem with the eye there. So, that we cannot see very clear image, only the image appears to be like blur image, that is. That is the definition of far point here. So, far point is the maximum distance that myopia defected eye can see the object very clearly. So, where we are getting the problem with the myopia is, when object is placed beyond that far point, after that far point, then we are getting the problem, we are getting a blur image is coming. Okay. That only we call that as myopia or short sightedness, that is. Then next question they are asking, it is about how to correct this myopia here. Actually, the problem with the myopia is, as I said, if we are placing the object beyond that far point only, we are getting the problem. Means beyond this far point here, before this far point to the least distance of clear vision, we do not have any problem to that. Okay. So, most of the cases when you are taking for the case of a normal vision here, normal clear vision without any defect, this far point value it is about infinite we have. Okay. So, means we can see the maximum distance that the maximum distance that having not any problem with the eye defect person can see the objects very clearly up to infinite distance, he can see very clearly. So, that is why the far point of a healthy person is about infinite we have. But whereas in case of this one, it is a fixed point we have, that only the far point distance we call. Okay. But if the far point, if you are taking the object before this far point, as we can see very clearly that myopia defected eye can see very clearly here. So, which means if you place the object which is after the far point, if you make that to come before the far point, then they can see very clearly the object here. Then it is possible to cure this myopia, it is possible if you are using one more concave lens here, because concave lens we are having a different nature, that is of diverging nature it has. When you are taking any of the object before this concave lens, it is forming the image which is virtual and erect, and it is forming very nearer to the lens here. So, that is why what happens there is we can see the object very clearly once it is very much closer to our eye lens. That way we can actually cure this myopia defect, that is. For example, like this, if you are taking any of the eye lens, so that here to this eye lens, now we are taking the far point here. So, as the far point here means, if you place the object before this, anywhere you can take, then what happens there is the image will be formed very clearly on the retina here, like this. It can show very clearly the image on the retina. But once if you place the object after the retina here, after that far point here, like this, for example, if this is the position of the object. If the object is placed after this far point here, then what happens there is the light rays are not converging here, means not on the retina, before the retina only it is converging here, like this. Here the image is formed. So, that because of due to that, as we are having less focal length is there than required of 2.5 centimeters. So, that is why the image is formed before the retina only. So, that is why when the light rays are passing over this retina here, we are having a diverging beam of light rays are coming. So, that is why here we cannot see the object very clearly, that is. Okay. Now, here as this is the problem, now we are going to take an object, so that we are keeping the object here before the retina here. Okay. So, means that is of we are taking the object here by using a concave lens, because the concave lens is having a special nature of diverging nature it has. So, that is why what happens there is, if you are placing any of the concave lens here before this object, then what happens there is the object which is placed after the far point here, whenever those light rays enter here, the image of that it is forming before the lens. Here it forms its image, because our concave lens forms a virtual image, that is, and that virtual image it is forming before the lens only, that is. So, that is why the position of the image is now coming in between the far point and the eye lens. Now, this image is acting like object for our eye lens, so that it can form exactly on the retina here, like this. Directly it is forming on the retina here, so that we can see that object very clearly. So, the main question they will ask on this myopia is here, which type of lens we prefer to find the to correct this myopia here, which is a diverging lens called concave lens, that is. Okay. So, they can ask the questions on this concave lens, that is. Okay. Then which type of concave lens we have to use, what is the recommended focal length for the defected eye. Okay. So, as we know that we are using to correct this eye lens, as we are using that concave lens here, then how much is the focal length required for this concave lens is, that is nothing but equal to f is equal to minus d centimeters, f equal to minus d centimeters. And what is that d is? D is nothing but here the far point distance, d is nothing but the far point distance, that is. Okay. So, d is the far point distance, equal to the far point distance. If you take the focal length there for the given concave lens, for this concave lens, f value is equal to d, that is. As we are having that is a concave lens if you take the sign convention, its focal length is negative. So, that is why f is equal to we have to take minus d, that is. Okay. So, now these type of questions they will ask if you are taking about a concave lens, that is. Okay. So, recommendable focal length for that is f is equal to minus d centimeters, that is, where that d is nothing but equal to the far point distance. Okay. Now, say for example, in the exam they will ask like this, if the focal length, if the doctor recommended a focal length of having the power f is equal to minus 2d, then which type of defect that person is affecting. Which type of defect means? Here mainly important thing we have to see is about the sign. Here the sign given, it is of negative, that is. This negative actually it is meant for the case of concave lens only. So, as it is of concave lens is given, this concave lens here actually we use for the case of short sight, which is called myopia, that is. Okay. So, now the given question, it is about short sightedness. The first conclusion we have to get on seeing the power of the eye lens given there, that the minus is given there, then that is nothing but it is about myopia we are taking. Okay. And also given that is equal to minus 2d, that is nothing but the power. In earlier classes we know that the power is nothing but the reciprocal of focal length, that is, or focal length is nothing but the reciprocal of power, that is. As it is given in terms of 2, that is, which is 2d diopter, that is, then the diopter is nothing but equal to the meter inverse, that is. So, 1 by meter inverse, that is. Okay. So, then it becomes 1 by 2 meters, that is. Okay. Then 1 by 2 meters, which is 0.5 meter, or you can also take that as 15 centimeters, that is. So, which means the far point or the focal length recommended for this defect is equal to 50 centimeters, that is, or we can also say the far point of this one is nothing but equal to 50 centimeters. That person is having a far point distance is about 15 centimeters, that is. Now, if you see one question here, if a doctor suggested a person to use a lens minus 1.5d, which defect the person is affected and what is his far point? Okay. Now, here as given that the power of the lens is given there actually, because it is given in terms of d, where d means a diopter, that is. Okay. So, the power of the lens P is equal to minus 1.5 d is given there. As the power is equal to minus 1.5 d here, we know that we can find the focal length from that, P is equal to 1 by f, that is. Okay. As P is equal to 1 by f, where P is equal to minus 1.5 d is given, is equal to 1 by f. Then f is equal to, from this we can write f is equal to 1 by minus 1.5 d, where d means meter inverse, that is. Okay. Therefore, from this we can write the focal length recommended here, it is about minus of 1 by 1.5, which is 15 by 10 we can write, and meter inverse on coming to numerator becomes meter, that is. Okay. Then the focal length becomes f is equal to 0.66 meters, that is. Now, if you see the question there, actually which defect the person is affected is given there. Actually here the recommended one is about minus 1.5 d, that is. So, as it is of minus 1.5 means here we are getting the focal length minus 0.66 meters, that is, or you can write that also as 66.66 centimeters, that is. Okay. As that minus represents about the focal length having negative means nothing but a concave lens, that is. As it is of a concave lens, that concave lens actually we use for the defect of myopia, that is. So, means this power of the lens, it is about to cure this myopia, the person which is affected with myopia, that is. And not only that, here the question given that what is his far point. Actually we know that the far point of the distance is nothing but equal to the focal length here, which is f is equal to minus d, that is. Okay. Means that far point distance d becomes d is equal to minus f, which is minus of focal length given there is minus 0.66, of which we call that 0.66 meters. Means the far point distance of the person, it is about 0.66 meters, that is. Like this, they will ask different numericals. By giving the power, we can find the focal length of the suggested there, and by using the focal length, we can also find the power of the lens which is recommended for that person. Like this, they are asking the numerical type of questions on myopia, that is. Now, we will see one more question, same as previous one. If myopia defected person has far point of 150 centimeters, give the suggested focal length to correct the defect and find the power of the lens used here. So, as it is given, it is about the far point here, which is of 150 centimeters is given there. Okay. As it is of given 150 centimeters is the far point distance, as f is equal to, that is of the far point distance, d is equal to given 150 centimeters, that is, which is nothing but the far point distance, that is 150 centimeters. We know that when the person is defected with this myopia here, the suggested focal length is also equal to our far point distance, that is. So, the suggested focal length is equal to nothing but equal to the far point distance d, that is, and that distance is given 150 centimeters, that is. But we know that we have to use a concave lens here. As it is a concave lens, the focal length we have to take, its sign convention is negative, that is. So, that is why we are taking d is equal to minus 150 centimeters, that is. So, the focal length suggested, if the person is defected with this 150 centimeters far point, that myopia is here, that is its suggested focal length becomes minus 150 centimeters, that is. Okay. Then if you want to find the power for the suggested focal length, then power is equal to, as it is reciprocal of the focal length here f, then p is equal to minus 1 by focal length given, which is of 150, that is. Okay. Then 1 by 150 we have, but actually that is taken in terms of centimeters, that is 150 centimeters. Then power, actually it is having the unit meter inverse, that is. So, that is why we have to change that into units of meters, that is. So, 150 centimeters we can write that as 1.5 meters, that is. So, finally the power becomes minus 1 by 1.5, which is 15 by 10 diopters, that is. So, 15 by 10 means you can cancel that with 2 there, 3 and here. So, that we are getting the final power becomes P is equal to minus 0.66 d, that is. This is the power of the lens he has to use, so that to correct this defected eye, that is, which is minus 0.66 diopters, that is. Okay. So, the suggested focal length, it is of minus 150 centimeters, and if you want to find the power of the lens used, the power of the lens used is minus 0.66 diopters, that is. Like this, depending on the given problem, we can solve, we can find the suggested focal length required to adjust the eye lens here for the case of myopia. And not only that, if a focal length is given, we can find the far point, or if far point is given, we can find the power or focal length suggested. Till now we will see how the questions are coming on short-sightedness, which is also called as myopia, that is. Now we are going to the next one, which is about hypermetropia here. Okay. Now this hypermetropia, which is we also call that as long-sightedness, that is hypermetropia, or it is also called as long-sightedness, that is. Okay. Now, short sight means we can see the near distant objects very clearly, but here it is about long sight. Long sight means we can see the far distant objects very clearly, but not the short distant objects. So, means actually if you want to see the long distant objects, so that the focal length to be adjusted is maximum, which is of 2.5 centimeters. So, as we can see the far distant objects very clearly here, so means we do not have any problem with the maximum focal length adjusting here. The maximum focal length we can adjust here, which is of 2.5 centimeters, is good here for our eye lens. Whereas, when you are seeing the near distant objects only, we are getting the problem with this defected eye. Means when you are seeing any of the near distant objects, we cannot see a clear image, only a blur image we can see. So, because these ciliary muscles, actually here it is not able to adjust this eye lens to 2.27 centimeters, that is. It is not adjusting the eye lens to 2.27 centimeters, means the accommodation of our eye lens, which is that ciliary muscles, is not adjusting properly, whereas this accommodation is nothing but adjusting to 2.5 centimeters or adjusting to 2.27 centimeters. That accommodation ability of that ciliary muscles to adjust to the minimum focal length of 2.27 centimeters, it is not capable there. So, that is why here we are getting this defect of hypermetropia. It is also called as long-sightedness. So, which means we can see the objects very clearly, which are of far distant objects if you are seeing. Whereas, if you are coming to the case of minimum distance, small distant objects, so that what happens there is we cannot see the very clear image, that is because the focal length of the eye lens is not 2.27 centimeters, it is always more than 2.27 centimeters only present. That is the problem with this eyesight which is of defected vision, hypermetropia, that is. So, the questions coming on this defect is, they can ask like this: if you are seeing a near distant objects, if the person is not seeing the objects very clearly, of which it appears to be like a blurry maze, which type of defect that is? That defect is nothing but hypermetropia, that is. The answer for that is nothing but called as long sight or hypermetropia. Okay. Or they may ask the same question like this also: if the person is affected with hypermetropia or long sightedness, then what about the ciliary muscles adjusting of focal length, or the ability of the accommodation of the ciliary muscles is? Actually, it can show the clearly the objects which are of far distance 2.5 centimeters very clearly, but not 2.27 centimeters. So, the ability of adjusting the lens here 2.27 centimeters is having the failure here. So, that is why we are getting the problem of this hypermetropia. This is the reason for getting the myopia, hypermetropia defect, that is, which is of long sightedness. Now, you will see, now the question will come about how to manage this hypermetropia or how to cure this hypermetropia here. Actually, the suggested focal length here, the suggested focal length for the eye lens to be used is nothing but called f is equal to, the suggested focal length f is equal to 25d by d minus 25, that is. Okay. And what is that d is? We call that as near point. We call that as near point. Okay. Here d means nothing but near point, that is. Near point is nothing but, as I said, we can see the near long distant objects clearly if they are having a long sightedness. To that we are having some minimum value we have to take, which means the minimum distance, so that hypermetropia defected eye can see the objects very clearly. That minimum distance only we call that as near point, that is. Okay. If once the person is defected with this hypermetropia here, any of the object which is placed from near point and after the near point, they can see very clearly the objects. But once if you are placing the object before this near point, then what happens there is they cannot see the object very clearly here. So, means if the object is after near point, we can see clearly. If it is before the near point, they cannot see very clearly. This is the defect of hypermetropia, that is. Okay. And the suggested focal length, as I said, 25d by d minus 25. So, that actually the lens here we are using is a convex lens, that is. That is a convex lens. Actually, sometimes they will ask about the diagram questions also, which means they will give a diagram here, for example, like this. In case of this eye lens, so that if the object is placed, which is, let us suppose this is the near point. For that near point, if the object is placed before the near point here, then what about the focal length here? What about the diagram here? So, the diagram is like this. Actually, here, as I said, the focal length of the eye lens, if you are seeing the near distant objects, then the focal length has to be less, which is 2.27 centimeters. But the problem with the ciliary muscles is it is not contracting up to that 2.27 centimeters. It is always more than that far point we have. So, that what happens there is the image formed by that means the light rays are going to meet after refraction after the retina here. So, that whenever the light rays are passing over that retina, they are not converging to a point. So, that is why again we are getting a blurry image here. This is the defected eye diagram. So, that when the object is placed before the near point here, before the near point, like this we have. Okay. Now, the suggested focal length, as I said, it is about a concave lens. Then means if you are using a concave lens for this eye defect, then what happens there is, if this is the eye lens and if you are placing the object which is of before the near point, if you are using, then the light rays are converged 2 times. So, that the light rays now exactly meet on the retina here, like this. So, that the light rays are appears to be coming from far distance here, like this. So, which means after the near point, they can say they are appears to be like coming here. So, that if once the object is coming after the near point, if object is placed at after the near point, we do not have any problem with that seeing the object. So, that is why here in case of long sight, we can see after the near point, that is we can see the object clearly. If it is before the near point, we are having the problem. Okay. So, for these suggested lens is the convex lens, because that convex lens, as the converging point is far after the retina, if we use one more convex lens, so that what happens there is 2 times the light rays are converging here, so that the converging point is now coming closer, and now it is forming exactly on the retina here. So that what happens there is, here the light rays which are coming from the object when passed through the convex lens here, of which we are using that lens, then the light rays are appears to be after convergence, that light rays are appears to be coming from after the near point here. So that the object which is placed after the near point, as it can see very clearly, so these light rays can see now exactly converging onto the retina, which means that we can see the object very clearly. Then how much is the focal length required? Suggested focal length for this one is f is equal to 25d by d minus 25, that is, whereas the 25 is nothing but our least distance of clear vision, which is our least distance of clear vision, that is. And this d, as I said, that is about near point. So that near point is always more than the near point, that this near point is always more than our least distance of clear vision, which is 25 centimeters, that is. So that's why the value of 25 into d and d minus 25, and this d value is always greater than 25, then it is going to be a positive focal length we are getting. Okay. As the focal length it is of positive, means nothing but we are using a biconvex lens here or a double convex lens here. Okay. So that is about how to correct this hypermetropia here. Okay. So main important questions on this hypermetropia long sight about how to adjust the correction of eye lens is, which type of lens we have to use, that is of we have to use a biconvex lens. And what is the reason for using that biconvex lens, means as you are using one more extra convex lens here, the light rays are converging one more time, so that what happens there is, now the image is forming exactly on the retina here. Now another question they may ask is about their near point here. If the near point is there, so that if the object is placed before the near point, then what about the image? Now, if the object is placed before the near point from the retina, if they are affected with this hypermetropia, then they can see a very blurry image. Or if the object is placed after the near point here, then how the image is formed? If the object is placed after the near point for this hypermetropia defected eye, then what happens there is, they can see the object very clearly, because the problem with the ciliary muscles is about adjusting the minimum focal length here, but not about the maximum focal length. As it can adjust the maximum focal length, which is of 2.5 centimeters, we do not have any problem with that. So that is why here we can see a very clear image if once the object is placed after the retina here. Okay, after that n value here, after n, where n is the near point, that is. Okay. So these type of questions they will ask about hypermetropia, that is, and sometimes they will ask about the numericals also on this, finding the far point or the power of the lens here, which is f is equal to its formula 25d by d minus 25, that is. Now we will see a question on this hypermetropia here. If a near point of the defected vision is 75 centimeters, then find the power of the lens suggested for correction here. So as the question it is about the near point, that near point actually it is meant for hypermetropia here, because we know that near point is nothing but the minimum distance that long sighted and defected eye can see the object very clearly, that is. So that near point is given as 75 centimeters, that is. So as d value, which is the near point, is given as 75 centimeters, that is. Okay. Then suggested focal length for this one, it is about that is of f is equal to 25d by d minus 25, that is. This is the formula to find the suggested focal length when the person is defected with this hypermetropia, that is. Okay. Then if you take the suggested focal length, f is equal to 25 of d means 75 centimeters by d minus 75, which is 75 minus 25, that is. Then it becomes 25 into 75 by 50, that is. So that we are getting 75 by 2, that is. This is of centimeters we are taking. Okay. Then whereas when come to the case of here, we have to find the power. Power is nothing but the reciprocal of focal length, that is. So as power suggested here, it is equal to P is equal to 1 by f. Then 1 by f, it is of 75 by 2 we have the focal length. Then it becomes 2 by 75, but here that focal length we have that in terms of centimeters we have, but actually the power we have to take in terms of meters, that is. So, that is why here if you want to convert that 75 centimeters into meters, then P is equal to 2 by 75 by 100 meters, that is, which is of, here it becomes that 100 come to the numerator by 75, that is, then 25 fourths and 25 threes. So, that you will get 8 by 3. So, whereas that 8 by 3 means here 2.66 diopters, that is. So, this is the power. But actually if you see here the focal length we are getting here f is equal to 75 by 2 centimeters, which is a positive focal length we are getting, whereas that positive focal length means that is nothing but we are using a convex lens, that is, okay. And not only that, here the power we are getting which is of a positive, that is, which is plus 2.66 diopters, that is. Okay. So, from this problem actually by using that near point we got the power which is of a plus 2.66 diopters here, and the defect of this eye is nothing but the hypermetropia, that is, because that near point it is meant for the case of hypermetropia, and the suggested focal length, that is suggested lens is first the convex lens, and the suggested focal length it is of 75 by 2 centimeters, and the suggested power to that one it is of 2.66 diopters. Like this, depending on the given problem, the data there, we can find by using the near point, we can find the power of the lens there, and also if you know the power of the lens, we can find the near point also. Here one more numerical we have, if the suggested power of the lens is plus 2D, then find the near point of the defected vision. Actually given it is there, we are having the power is given plus 2D, that is. So, positive represents that is about the convex lens. So, that actually that convex lens we are using only for the case of long sightedness, that is the first conclusion we have to get, and given that that power it is equal to 2D is given there. So, we know that as power P is equal to 1 by F, then 2D is equal to 1 by F, then F becomes 1 by 2, that is. Whereas this we are taking diopters, diopter it is of a meter inverse, that is. So, that the focal length we are getting that in terms of meters we have. So, that f is equal to 1 by 2 means 0.5 meters, or we can also write that as 50 centimeters, that is. So, the focal length we are getting here it is about 50 centimeters we are getting. Now, what we have to find is the near point here, which is the d value we have to find. But we know that to get this suggested focal length f is equal to, which is 25d by d minus 25 is there. Then from this we know that as focal length it is about 50 is there, then we can write f is equal to 50 is equal to 25d by d minus 25, that is. Then if you cross multiply that, then you will get d minus 25 of 50 is equal to 25d, that is, of which you can cancel that. So, that you will get 2d minus 50 is equal to d, that is. Then if you bring the d this side, then 2d minus d is equal to 50 and d is equal to 50 centimeters, that is. Okay. So, means the near point distance it is about 50 centimeters we have. So, that the power of the lens is given it is of 2d, that is, and the focal length here it is of 50 centimeters. So, that if you are using a suggested focal length of 50 centimeters means we are getting the power of that suggested near point actually for that defected vision is around 50 centimeters we have. Like this, the problem if you know the power of the lens of which they are using, then we can find their near point, and in the same way we can find depending on the sign convention which type of lens they are using. As we got here that is of positive, again we are getting here the positive means positive represent about a convex lens, of which that convex lens actually we are using that for correction of hypermetropia, that is.